So for number 1, when you're evaluating, you're asking yourself, log base 2 of 8 is what? I like to put the question mark in here to say what is the value. So we get rid of the log, we convert to exponential form by bumping the 2 to the other side. So the question mark goes up. The question mark is our answer, right? So 2 to what power is 8? And the answer is 3. So log base 2 of 8 is 3. 3 is our answer. Second one, so we get rid of log. We say 27 is equal to 1/3 to what power? Okay, when you have a fraction, think of a negative power. So 1/3 to what power is 27? Well, it's -3. -3 is our answer. Because 1/3 to the -3rd, we flip 1/3 to 3 over 1, and then the power, the exponent becomes positive, and 3 to the 3rd is 27. So the answer again is -3. Okay, so when we look at logs, think Rx. So R means the range is all reals, and our domain, our x, is going to be restricted. So first of all, we look for the asymptote. When we look at log base 5 of x, we set what's beside the x equal to 0, so we get an asymptote of x equals 0. So we do that dotted vertical line, that's our asymptote. We can't touch or cross. Then when we make a table, we find some points, we plot those points, and we draw our sketch. Since the graph is on the right side of the asymptote, we would say the domain, or the x values, are greater. Greater means to the right. When you're trying to find ordered pairs, you can pick any x values greater than 0 that you want to plug in. So I plugged in 1, I plugged in a 5th, and you can either use your calculator, hit trace, enter, or you can evaluate it by hand. So for example, if I was going to evaluate this by hand, you have two options. You can say log base 5 of 1 equals what, like we were doing before, cross off the log, bump the 5, 1 equals 5 to what power? So 0, 0 is your output. So the word pair is in when 1, out came 0, 0 was the exponent. If you forget to use the trace feature once you have the graph in and you hit trace 1, enter, you can also use change of base. So you could plug this in your calculator to evaluate as log of 1 divided by the log of 5, and that will give you the answer. Okay, so for number 4, you first need to isolate the base 4 raised to the x plus 1. So we first add 7, so we get 21 on the right, so right here. So then we look on the side that the variable is on, and we need to get rid of this base 4. So we need log base 4 on both sides. On the left, it cancels, log base 4, 4. So that's why you're left with x plus 1. And on the right, you have log base 4 of 21. Now log base 4 of 21, you can put that in your calculator, and you'll get out the number. It's about 2.2. So then we isolate x by subtracting 1, and we end up with about 1.2. Number 5, if you have one term on both sides and they're both log same base, you can cross off log same base, and you're left with 5x plus 8 equals 13x. You solve for x, and you end up with x equals 1. That's a 1. So for this starred one right here, your options are create same base, or C log, get rid of log, don't C log, if you see exponent, add log. So you can't make same base for this problem. I don't see log, so I need log. So that's why I apply log base 2. You know that it's base 2 because you're trying to isolate the variable, so you look at its base. So we do log base 2 on both sides. On the left, log base 2 of 2 cancels. So we're left with x equals log base 2 of 6. You can put this in your calculator, again, as log 6 divided by log of 2, and you'll get 2.58. Okay, this next starred one. if you can create same base, go for it. So I have base 3 here. So I ask myself, can I rewrite 1/9 as 3 to some power? Yeah, you can. You can rewrite it as 3 to the negative second. So we have same base 3 on both sides. Like, cancel out. We're left with x minus 1 is equal to, now don't forget to distribute the negative 2, because power to a power. So we get negative 2 times 2x is negative 4x. Negative 2 times 4 is negative 8. And when you solve, you end up with x equals negative 7/5. So number 6 is pretty easy as well. You have one term on both sides, so you can cross off natural logs. They both have natural log, and you just set 4x minus 2 equal to 8x. And when you solve, you get x is 1/2. Now, this last starred problem, you see log, so you get rid of log. The 6 goes to the other side. So you're left with x minus 4 equals 6 squared. Right, the 2 pops up. So then when we solve, we have x minus 4 equals 36, and we add 4, and we get x is 40. I think some of that got cut off.